Hey guys, so you may have just come from the video where we looked at how to graph parametric equations by hand using a table. So here I'm going to share with you how you can use your graphing device. I have the TI-84 Plus C Silver Edition. So the buttons that I go through, the mode that I use, really should be the same for any TI-84 or maybe TI-83. I'm not quite sure how this translates to the Inspire or any Casio calculators, but I'm sure there are other videos out there. This is for the TI-84. So the very first thing that we're going to need to do if we are graphing parametric equations is we need to change the modes. I'm going to put a little list here of what buttons I'm selecting, options I'm choosing. So the very first thing is that we need to select the mode. So that's an actual button we select, so mode. And then off of this list, we want to select parametric. Okay, so looking down, the default for these calculators, the default is function, so we want to change this to parametric. So you can see my selection there. All right, so once you have that, you are ready to graph. So let's go to our y equals. Okay, now notice that our screen has changed from the typical. Typically it's y1, y2, y3, and so on. Now we have x1t, y1t, and then another set because parametric equations have an x component and y component. So we are going to go ahead and graph really the same functions with some additional ones, the same functions as the first video here within this topic. So the very first set of functions we're going to graph here, I'll place it on the screen for you so it's easier to see. It's going to be t plus 1, and then t squared plus 2t. You might be noticing, oh my goodness, typically up to this point it's been just x, and now it's changed to t. Well, when I change the mode, it recognizes that parametric equations are with respect to t. So we have that. So I insert whatever equation I'm dealing with, we're dealing with this parametric equation. Now, once you've done that, so let me write this down here for those who are following this list, is we entered the parametric equations, I should say. Okay, so the next thing we do, a little bit of a shadow here, maybe that's going to help doing that. There we go. The next thing we're going to do is alter the window. So this, I'm pretty confident in saying that this will need done almost every time. So our window is again right beside y equals. Okay, and we have this. So notice t min is 0, t max is, well, 6.28. We need to change this depending on the range we want to see. Okay, so you notice that we wanted from -3 to +3. So -3 is our t min, +3 is our t max. For the t step, unless you're told otherwise, actually here I'm going to show you what happens if I just choose 1. So I'm going to choose 1 because that's what we did in the other lesson. We just went by 1. Now our x min, x max, we can right now leave it b, but I know that we're going to need to change the y max to 15. I'm just going to write down what we did here. We changed the t min, the t max. Okay, so this will be often given to you. Just so you know, it's given to you. We altered the x min and x max, y min, y max. Again, you have to go back and forth and change that to get a good view. So the t step, I want to say the t step, you start with 1, but typically our t step, we're going to want to set something small. So I like to use 0.01 as a default t step, but we chose 1 for now. So now we're ready just to hit graph. Okay, so we hit graph, and there we go. So you notice the motion was very quick when it did it, but notice how it's kind of like broken into little segments. That's because of our t step. The t step was 1, so it's just very short segments. So if I go back to change our window and change that t step to 0.01, which will be typically, and then graph it, one, it goes slower because it has a smaller increment, but it gives us a nicer curve. So we see here, we have our function. Okay, so let's try another set of parametric equations. Let's see here, put this on the screen. So what do we got? X equals t squared minus 2, and y equals 3t. Okay, so t squared minus 2 equals 3t. Notice if I've already done a problem of one of these, it's already in parametric mode. Okay, but if it's always good that you go back to mode and check that you're in parametric. So we have this. So we now, our window, because we see here we went from -2 to 3. Let's leave this 0.01 t step. And I think everything else should be good. We could possibly change this back to +10. So let's graph it and see what we get. There you go. So notice it actually has endpoints. It has endpoints because of our t-step, or sorry, our t-min and t-max. So if I alter that t-min, t-max, we'll get a different visual of it. Maybe, just maybe, if I would have selected from, I don't know, a t-min of +5 to a t-max of +15, we would not get this, what do you want to call it? The inverse of a quadratic equation. We would not get this curved appearance. Let me just show you real quick, since we're talking about it. So t-min of +5 to let's say +10, or no, let's say 15. Okay. See, it's not even going to show up on the screen. Should have known that. So, anyways, let me just do this, 0 to 3, because that will do what we need. Yeah, so we don't get a good visual of we don't get a good picture. That's why the intervals, the time intervals make a big difference. Okay, so let's see, what's our next one we have? X equals 3 cosine t and y equals 3 sine t. So we have 3 cosine t, 3 sine t. It's important to note our interval. Our interval is from 0 to 2 pi. So I want to say this. If you notice your interval is from 0 to 2 pi, what mode do we have to be in? Well, we have to be in radian. So notice this is in radian already. That it makes a big difference. A big difference. If you're trying to look at your t-step in terms of radians, but yet it's in degree, just make sure that your radians, degrees match up with your equation and your time interval, all right? So we go to our window. So we want our t-min to be 0, our t-max to be 2 pi. Yep, I put a good old 2 pi in. And then our t-step originally was pi over 2, so let's do pi over 2. Okay. And we can actually bring this down some. Let's see, -5 to 5, -5 to 5. So we graph. So see what I said this before in the other video. This is what we get. It goes from one to the next point, to the next point, to the next point. We know what this should have been, but because of the t-step we chose, we get this picture. So now if I go back to my window, and we do pi over 6. Okay. Again, not quite a circle, but it's getting closer. Let's do zoom. Let's change this to zoom square. That way there's no distortion. There we go. So it's getting closer to a circle. Let's change this to pi over, let's do pi over 6. Let's do pi over 64. I like that, pi over 64. And there we go. By this point, pi over 64, that's a really small increment. And we have our good old circle with a radius of 3. So that was all that was in the previous video. So I have a couple more here for us to look at. See what do we have? And these are going to look very, very nice. Okay, so you see it on the screen. We have to type this in. 2 cosine of t plus 2 cosine of t, and we have to square that. So the exponent we're going to have to put on the outside of the parentheses. All right, and the y component, 2 sine of t plus 2 sine of 2t. Okay, our window, we can just leave it 0 to 2 pi. I can tell you while getting this video set up, I made the mistake of having degree and not radians, and I had my T max. I had to make it to like 100 pi, because I could not figure out what was going on. So again, knowing our intervals 0 to 2 pi and not 0 to 360, we have to be in radians. Our T step, let's leave it as pi over 64. Let's graph it and see what we get. Let's do -10, +10, -10, +10. All right, let's graph this. Oh, look at that. Probably, I bet you weren't expecting that. So let's change our window to get a closer view. So let's do -5, +5, -5, +5. Just zooming in a little bit. Yeah. So this is probably your first time seeing a curve like this. It's not a function, I can say that. It's interesting that the parametric equation we got gave us this. So yeah, let's see what happens when I change that 2 cosine t plus to 2 cosine t minus. So remember this picture. Let's go back now. So I put the new equations up. Change it to a minus. So what do you think is going to happen? Just converting the addition to subtraction, what do you think is going to happen? Well, let's find out. Wow. So again, I'm pretty positive you're not expecting that. So we don't even have a name for that type of curve. Maybe there's a name that exists, but it escapes me right now. So let's look at one more set of equations, parametric equations, and see what we have. Okay, so clear this, clear this. Let's see. Because we have 3 cosine of t, and then sine of 2t. Okay, so we're still in radians. That's our mode. Let's try leaving this be and see what happens. Oh, that's nice. So I believe there's a name to this, but it's just, we can all say it looks like the infinity symbol, infinity sign. So that's it. So I would be surprised if you do not find this interesting, how the various equations give us these beautiful graphs. So I'll just show you. I'm going to change this 2t to a 3t. So notice 2t gave us the 2 sections. 3t hey, 3t gave us 3 sections. What do you think is going to happen if we do 4t? Is it going to give us 4 sections? Let's find out. And wouldn't you know it, it did. So what about 5t? I'm just messing around right now. 5t. So it's just amazing. We could really play with this more, but the idea with this video is just getting used to how this graphing utility device, this graphing calculator, how we can use it to graph parametric equations. So good luck. If you choose to use this, I know it is still it's a necessary skill. It is an important skill to know how to graph these by hand. Having a table, getting your x component, your y component, and plotting them. That is very important here. All right, but I hope this is helpful. If it is helpful, please smash that like button, hit that like button below here, and if you have not yet, please subscribe to get more of these lessons, to get more of these videos, and hit that bell to get the notifications, guys. And I'll see you in the next video where we're going to be talking more about parametric equations, and see you then.